Alright, now we're going to find the y-intercept for this equation, 4x minus 3y equals negative 6. Now, again, you don't need to write this down. I'm just going to go off on a tangent for a second. Just watch and here, draw a nicer one. Watch and listen. Y-intercepts are where the graph of an equation touches the y-axis. And of course our y-axis is the vertical axis. I'm going to put some points on my y-axis. That should do it. Okay. The name of this point right here is 0 for x, because I didn't go right or left, and up 2 for y, 0, 2. The name of this point on the y-axis, which also has to be on the x-axis, is 0, 0. This one looks like it's going to be 0, negative 1.5. And this one is 0, negative 1, 2, 3, and maybe 2/3. Okay, now question, what do all these coordinate pairs that could possibly be y-intercepts, because they're stuck on the y-axis, what do they all have in common? And of course by now you should have noticed they all have an x value of 0. So if we want to find a y-intercept, that is, we let x equal 0. Notice what's going on here. X-intercept, let y equal 0. Y-intercept, let x equal 0. What does that mean? We replace the x in the equation with 0 and solve for y. So here we go. For pocket, because we're going to take x out, subtract 3y equals negative 6. What's going in the pocket? 0. Remember how I talked about this being the cover-up method? Basically, 4 times 0 is 0, and it's just going to make this whole term go away. And we're just going to get this mini equation, negative 3y equals negative 6. I could write 0 subtract 3y equals negative 6, but hey, let's take a shortcut this time. Let's just bring down this mini equation, because that's going to go away. And all we have left to do is divide both sides by negative 3 in order to solve for y. And we get y equals negative 6 divided by negative 3, which is positive 2. Alright, now we want to write this as a coordinate pair so we can graph it. So our y-intercept, remember, x was 0, and y we found out is 2. Alright, we're almost done. Next we're going to graph these two coordinate pairs. The x-intercept, negative 1.5, 0, and the y-intercept, 0, 2. Let's get our graph ready. This is really a tiny grid, so what I think I'm going to do so we can see it well enough as we're graphing is use 2 spaces for each unit. On both, let's do it on both the x and the y-axis. Even though we wouldn't have to make them the same on both axes, let's do that. So, 1, 2, 3. Remember, you do need to number when you're changing the value of a unit. 1, 2, 3. And make sure you skip 2 spaces for every single value you're labeling. Negative 1, negative 2, negative 3. Negative 1, negative 2, negative 3. So again, we're labeling our axes. We're skipping 2 spaces for every unit. Take a second to finish that up. Alright, we're graphing negative 1.5, 0. Remember, that's a value somewhere along the x-axis because it's the x-intercept. So where is it? It's left 1.5, and we're stuck on the axis because y is 0. The other point, 0, 2. Remember, it's a point somewhere on the y-axis because it's called the y-intercept. Where is it? 0 left or right for x, and up to 2 for y. Now I have my y-int here and my x-int here. All we have left to do is connect these 2 points with a straight line very carefully. Alright, now this line goes through a lot of other points, an infinite number of points, not all whole number points, but I could pick any one of those points along this line and it would be a solution that would work in this equation. These 2 points are just 2 of them.